Next up, we are going to be taking a look at the range of sine and cosine functions. And boy, is this going to be a doozy. So let's go ahead and take a look at some graphs. First of all, let's just look at the top here. We're going to start at the first graph. So let's look at the original. Let's move this around a little bit. Let's look at the original sine function. We see that the range, remember the range is the possible y values, so you start at the bottom and you move up. We can see it starts at -1 and goes up to 1. So it indeed includes those values. Now what I want you to focus on is the center of the graph. Okay, that's really the middle of the range, right? Now, if I added to the center, if I added the amplitude, can you see that you would get the highest range value? And if I took the middle of the graph and subtracted the amplitude, I would get the lowest range value. Let's look at that algebraically. So 0 minus the amplitude, remember amplitude is always positive, so I'm going to put absolute value bars around it. 0 minus 1 would give you -1, which is the start of the range, and we're going to put brackets around it. And then 0 plus amplitude, 0 plus 1 would give you the highest range value. Therefore, the range of this graph goes from -1 to 1, including those values. So in general, the range of a sine function is going to be d, as you're going to see, is going to determine the middle of the sine wave. And in this particular case, d is 0, as you can see. So if I take the middle d and subtract amplitude, that's my lowest range value, and d plus amplitude is going to give me the highest range value. So let's keep looking. Let's look at another graph. Let's make d equal to 2, and then just make sure the amplitude is 1. Okay, so I'm going to change my d value to 2. I'm going to keep my amplitude at 1, and as you notice what happens, the middle of the graph moves up to my d value of 2. It's no longer at 0. So you can already visually see that to find the lowest y value, you take d and subtract the amplitude, and then to find the highest y value, you take d and add the amplitude. Just like this, 2 minus 1, 2 plus 1. Therefore, the range is 1 to 3, as you can visually see here. Okay? Let's look at another example. Again, this is all visual for now. What if d is 3 and the a value is -4? So let's make d equal to 3. Let's make a equal to -4. Looks like we're going to have to zoom out some here. That'll work. Okay, so if our theory holds, we're going to do d minus the amplitude and d plus the amplitude. D is 3, 3 minus 4 is -1, 3 plus 4 is 7, and that indeed gives us the range of sine. So 3 minus the absolute value of -4, because it's got to be amplitude, so positive, and then 3 plus absolute value of -4, and indeed we do get -1, 7. Let's do one more. Let's do 0 and -0.5. So we're going to keep d at 0. And we're going to make a equal to -0.5. I'm going to have to zoom in here. As you can see, indeed, it is 0 minus the amplitude. So it only goes down to -1/2. D minus the amplitude, and then 0 or d plus the amplitude goes up to 1/2. So in general, the range will always be including the first value, d minus amplitude, comma, and then the highest value, d plus the amplitude, including that value. That will be your minimum and max. Next video, I will show you a formal proof of this. If you have any other questions about these visual illustrations, let me know.